Okay, great. So I started off by saying that we're going to look at business intelligence today. We're going to look at big data analytics. We're going to look at data science as well. We're going to look at how these are built up from a basic foundation. And we're going to look at how we align this to strategy. So let's continue. So let's look at the basics, right? When we talk about data, everyone understands that data reporting, you need data to create reports. And at the very simplest, we store data. And when we store data, just as how you store it in your laptop, you've commonly looked at gigabytes in terms of your RAM, your hard drive. And, when we talk about data, there is different scales that we can look at it. In some organizations, they have a little data compared to some large organizations. Large organizations, for example, like your Walmart, your Tesco, large retailers, right? They collect data of a lot of consumers and how they are purchasing goods from them. So this you can imagine, we have a lot of data created, and over time, historically, this data builds up. So for some organizations, this data gets quite huge. We're not just looking at gigabytes that you store a few movies in. We're looking at terabytes, petabytes as well. And guess what? If you are keeping history for 5 years, it's going to be quite large. But if you want to look at trends analysis from the past 10 years, then you're going to go into much data, a much larger set of data. Now, this very much depends on your strategy, right? What type of business are you in? And what is relevant to your business? Are you looking at historical sales, for example, for 5 years? Are you looking at 10 years? When you are forming data strategy in your organization or for a client that you may be consulting for, these are factors that you've got to take into consideration, right? And if it's a new organization, fair enough, the data is not going to be quite large. But as time progresses, this data is going to grow, right? So you have to build that strategy, but early. Now, in its simplest form, and as you have gone through your courses, whether it is your undergraduate or now being exposed to it in your postgraduate, you're going to learn about data. How is that data stored? Not on a hard drive specifically, but how is the architecture, the structure of it in the servers stored? Now, when we look at data, we can look at different sets of data. There's customer data, there's purchasing data for what we may purchase from suppliers. There's master data of our customers and suppliers, which includes details like, for example, their contact names, addresses, phone numbers, who the contact person is as well, right? Even employees, we keep data about them, right? If consumers are purchasing from us, there's going to be orders and there's going to be products linked to that, right? Look at that, products. And even when we look at products, there's certain information that we keep about products. The name, the description, the size, etc. Right? Now, all of this forms part of the databases. And you can see logically in the databases, these are set into tables. And these tables are aligned to certain aspects. For example, customers, products, which we commonly refer to as master data. This transactional data, for example, sales orders that you also get. And this is formed of your master data, right? The basics of it, this is how a database is composed. So what is a database? Databases can be quite complex. And you get database engines that manage creating a database, what information is returned to you, as well as what information we include in reports. Now, let's take it a step further and look at data types. Remember, depending on what business you are in, there may be certain data types that you're storing. Now, let's have a look at that, right? Remember, we looked at the table earlier and we looked at customer info records, we looked at supplier info records and products. Now, we store information like names, contact info, address info, that's structured data, right? Because it's structured in that we know a name is alphabetic characters. We know a phone number is numeric characters as well, right? Now let's talk about unstructured data. Unstructured data, for example, is photos, pictures that we may have. Now, any image, perhaps taken of this class, if we're in a physical room, with a Samsung phone, for example, may very well be different from a iPhone. Now, that is unstructured data because we can't always determine how large an image is or a video. Now, depending on the nature of the reporting that you require or what company we are working with and information, this may differ. Some companies don't have unstructured data like images, audios, and video records, but others may do have only structured data. So here's a comparison of those different data types and the storage location, the flexibility of how we use the data. How did data evolve over the years? If we look back at when we first started keeping data, data was kept in the form of marketing. When we were marketing information, advertisement material to consumers, they needed to know how to get that brochure to the consumer. And in doing so, they needed to know, okay, if it's going to go to a certain person, that person is in a certain city. And how did they sort this out? So for the postal service in the mid-90s, what happened was they created postal codes. And that was the earliest set of data that has been created to be able to sort and identify how many letters or brochures need to go to a certain area based on us keeping customer records. We've got X number of customers in this city, and that's the postal code, and that's how it was sorted. So data evolved very early from postal codes. Now, what's the transactional data we keep? It evolved from the point of just keeping postal codes to who bought, where was it, and how often. So data started evolving, and we started keeping more data sets. Now, we wanted to evolve and target certain cities or certain demographics. And when we look at demographics, we talk about descriptives, attributes that describe the population, for example, right? Gender, male or female, age, marital status, how many dependents, children you may have, and income, right? And so they knew that, okay, for luxury goods, I can target certain income bands. If I'm selling electronics or, for example, PlayStations, Xboxes, I'm going to target a specific gender. And these have evolved as well, right? And we've got to consider that data attributes as well. Now, in defining any report, you've got to identify your business needs. And you've got to align it to certain business objectives. What's the requirement? What's the goals? What key performance indicators you are going to fulfill? And these are the simplest of questions that you'd ask yourself when defining a strategy and the earliest of reports that you're creating. Even such, when you are creating new reports, you're going to have to look at these variables and look at how you're going to form them. You need data, right? Where is your key data sources? And do you have the data or are you collecting it? And where are you collecting it? When you're forming the data analytics process, you're going to have to go through these simple questions and you're going to have to liaise with stakeholders in your business, right? So let's have a look at next step, which is collecting and preparing the data. Remember, not all data is clean, and in the type of form that you may be able to derive specific analytics from it. Depending on where you're collecting this data, if it's internal, it may conform to your needs. But if it's external, you're going to have to put it through some QA process, right? And then once you've done that, it's a report creation, right? And deriving certain analytics, business intelligence from that. So that also comes with how you're going to visualize the data. And in this design process, the expectation of your clients, your stakeholders, the end users of this is what you need to meet. And if there's certain visualization aspects where there's charts, specific graphs that you need will be defined in this step, right? So the data analytics process is about developing insights. And in that intelligence process, you want to deliver intelligent analytics, analytics that your business, your consumers, your end users can act on. Now, the data analytics process it comprises these steps. When you look at different industries, data analytics, business intelligence has many uses. Customer analytics, as we saw earlier, was looking at demographics, what they purchase, certain demographics purchase certain things, how does it differ, and being able to market to them very specifically. And reporting can actually guide you, your commerce, your commercial teams, your marketing function to targeting specific demographics. Fraud and compliance. In banking, if any of you are from the banking sector, business intelligence is used to detect fraud and compliance. And based on the rules that you set, it will monitor purchasing patterns and drive analytics for risk departments, for example, where they're able to, based on your purchasing history, where you're purchasing from, identify certain purchases that are not in your historical purchase patterns. And when they identify this, they're able to flag that as a risk. And have you ever got a call from the bank when you just made a purchase, be it even at the middle of the night, just calling to verify that it was you that did this purchase? At the heart of that is analytics, and that those notifications that send that to the risk team. So let's look at healthcare. In healthcare, analytics is used in development of medication, for example, certain antibiotics, in trials, but also once it is in the market, what's the outcomes of this antibiotic or any other medical, any other medicines that they may have released. And by getting information back from hospitals, for example, doctors about those outcomes, and what outcomes we're talking about? We're talking about outcomes in terms of success of it in, for example, curing certain diseases, and getting people healthier, building up resistance, those type of variables, right? But how do we measure them? In trials are small and with a certain population size. But once it has been commercialized, healthcare companies can use this data that's collected and shared back to them from the hospitals to identify, is it successful? How do we change it? Do we introduce a change? Now let's introduce a change and see what the effect, that outcome of that has been. Has it been positive? And this is used in research and development, right? So there's also sports. And in sports, you've seen, for example, with soccer players, the distance that they've run in the game, that is all measured, and statistics is developed off that, right? And those statistics are even used when players are being looked at for their health, their performance, and how do we price a player in terms of the transfer market. So the analytics has a lot of use cases. It differs by industry, but sometimes you can actually learn from other industries, and that's where the cross functional usage may come in as well. So there's many other industries, data mining, and data mining is about looking at the data and as the term suggests, mining, searching through the data to gather information and derive insights. When looking at business intelligence, you can't ignore statistics and using statistics analysis to derive or infer your results for better analytics. So we spoke about data mining, right? Let's have a look at the process of data mining. We touched on it earlier. It's about gathering data, right? Preparing your data. Your data may need some quality assessment done on it, right? Before you start mining the data. Mining the data is drawing analysis from it, and then looking at interpreting that based on your initial requirement, right? So we had a look at a few use cases before, and this just talks to that. So sales forecasting, we spoke about that in terms of marketing products to specific demographics. There's also basket analysis to look at what consumers are buying and look at if there's any trends, if there's any cross-functional relationships amongst products in different categories. There's also different use cases, for example, in the call center industry for call recording analysis, card marketing as well, right? Now, there are different use cases, and we won't cover all of them in detail, but let's have a look at one aspect that we spoke about, data visualization. Now, many of you guys may have been exposed to different types of tools and platforms. So tools and platforms, for example, differ in the way that they present the data. And when we look at big data, large volumes of data that we may keep, we're looking at how will we visualize that? And remember, with your end user in mind and your corporate or the industry that you are working within, you may look at certain ways of visualizing that data. Now, for example, you would have heard of Tableau. And Tableau, if you go to the website, you'll be able to see how data is visualized. And this is large data sets that we're looking at, right? So we spoke about gathering the data, cleansing the data based on what our key requirements are, right? And then deriving certain insights from the data. If you think about the insights we're deriving, finance and marketing teams may look at different data sets, different logical analysis of viewing that data. And this is where data visualization comes in. If you think about at what a level your end user is, at an executive level, at an operational level, you're going to have to set those reports to conform in a manner that they can use it to drive insights, for example, at the operational level or at an executive level. So Tableau, for example, allows you to drill down into certain aspects and right down to the product in terms of sales as well. There's timelines that you can look at. And when you look at different attribution, there's regional and there's even by category, right? So Tableau is a great product to play with. And if you're looking at wanting to visualize how Tableau gives you this data, have a look at the website. And there is a link here that you'll be able to use. And click that and you'll be able to have a look at the data and play around on the platform. Now, Tableau is expensive to have a license to it. Not all corporates do have a license, but as I mentioned, the platform would differ from corporate to corporate. So visualization is an important factor. And in terms of your strategy, you're going to have to always incorporate visualization into your reports. With today's platforms, visualization is very much possible. We no longer battle with CPU usage and limited data sets where we just view them in Excel or, for example, mainframes where it was just data, no graphics at all. So many of you would have heard or have been exposed to SQL. SQL is structured query language, and SQL is used by quite commonly many IT support functions. But being in the space of business intelligence, data analytics, data science, SQL is one of the very core skills, the basic skills that you will need to know for development of reports. Even when querying databases, SQL is a good handy skill to be able to use to query data and form insights towards developing your ultimate end goal of a certain report. Now, SQL it's not a programming language specifically, but it's very structured in that it has specific commands that you would use to interrogate data. We spoke about statistics earlier. Now, if you are looking at business intelligence, and especially data science, Statistical analysis is really important to use to derive insights. A few basic terms like population, sample populations are small populations, small sets of data that you would use to determine insights, and population being the whole population that you may have. But remember, when you're developing reports, trying to develop analysis, you can't go and look at 10 million people. The data set is too large, and some corporates can't keep data sets for 10 million people. For example, healthcare companies may not keep 10 million people on the database and try to develop a antibiotic or certain medicines, right? So they will use a sample size, a much smaller size, for example, possibly 1 million, and use that to derive analytics. So there's variability and central tendency. Those are basically averages, and this is how we visualize that data. There's different types of statistical analysis. There's descriptive statistics and inferential statistics. And this is where we work with smaller data sets. Descriptive statistics describes our data sets, but remember, inferential statistics is used to look at a sample and then infer that to a larger population. If we had certain outcomes for 1 million tests in a sample, those results could very well be true for a population of 10 million. So statistics really helps in terms of deriving good analysis, especially when you're doing research or trying to derive analysis for larger data sets or population. We spoke about data collection. There's different type of data collection that you'd use, and those are simple, stratified, and cluster. In terms of collecting data, simple random sampling, not using, for example, demographics, collecting of certain males or certain females or certain income bands, is the different types of sampling that you would use as well. Okay, so statistical analysis is very useful in reporting. There's hypothesis testing that you would use, for example. Hypothesis testing is, for example, to have a theory and try to test the theory based on your data. Now, if we're using business intelligence reporting, you'd be able to use that to determine whether, let's remember the example of an antibiotic. Was this antibiotic effective in certain population groups? Was it effective for certain demographics, for example, males or females? And confidence intervals is basically, I'm 90% confident that this is going to be a good outcome. So statistics goes into these type of variables and measures. So let's look at descriptive analytics. Now, descriptive analytics, we mentioned this before, describes the products that you're looking at, and based on how you use them, right? Now, let's look at analytics maturity model. Descriptive analytics basically looks at what happened, right? For example, let's look at a simple type of illustration. When you go to the doctor, he will ask you to describe the problem that you've had, essentially what has happened. And then he would look at diagnosing you, right? So why did it happen? And sometimes it's a question, right, that he asks you. Were you out in the cold, for example, or you exposed to certain environments that could have caused an adverse reaction? And based on that, he would predict certain outcomes. So if you don't treat it, what would happen? If you treat it, what would happen next, right? And so prescriptive analytics. Think about the prescription gives you certain antibiotics, medicines, and that is to direct the outcome to a specific path. So how to make it happen, right? It's a useful example, right? But look at that, descriptive, diagnostic, and when we're developing our analytics, right, this is based on what we are trying to achieve and what outcomes are we trying to predict. So based on your strategy, remember, and how you're using your reporting, you're going to look at these type of factors. What do I want to predict? What outcome do I want to have? So if I want to increase sales, what do I need to get that to happen, right? And if I have sales in a specific product, and if I want to market to certain demographics, because I think that would be a good outcome, then that's a hypothesis, right? And so we want to test that outcome and will that work? So in your research and development or in the commercial functions, these functional teams will look at different types of analytics to derive whether they'll have optimistic outcomes for some, for example, for some products that they're selling or developing, right? So analytics not only helps from knowing what happened, it helps in terms of guiding teams, research and development teams, to know which specific variables, outcomes will be optimistic and favorable, right? Okay, so moving on. So you have different types of analytics maturity models, and we looked at a simple one before, and this is another iteration of how we collect data, how we actually explore that data with different batch processing reports. How will we use this to help our functional teams derive analytics, whether it's at a high level, an exec level, or it's an operational level, right? And what we want to predict and prescribe. So there's different maturity models you'd have, and sometimes may differ by industry to industry, but at the end of the day, they're very basically the same 5 steps that we look at. So when we're looking at our data analytics and developing our reporting, there's one thing that you've got to look at in terms of that reporting that you develop, and that's telling telling a story. And you would see that in that report that you create, you've got to create a picture, a story, a narrative that guides your users in terms of what has happened, what they expect to happen, and it very much depends on the maturity of your organization and the objectives, the KPIs that you're trying to achieve, right? So that story from basically the data that you're collecting, the demographics, the variables that are inputted into it, and how you visualize that must be able to tell a story and engage your end user. So part of that strategy is to ensure that the reports are engaging, because you certainly don't want business intelligence to be delivered, but be biased, for example, to perhaps a BI developer and not to the business's real goal, how it aligns to their key performance objectives. And in developing business intelligence, working with your stakeholders, and that's your functional teams in business throughout the process, is key to ensuring that your strategy aligns to what their outcomes needs to be. So quite simply, considering your audience, those stakeholders who are going to use that report, is very important. Identifying what type of data visualizations is key for that, and giving them context is part of the storytelling. So structuring your story is so important to keep them engaged, but also to ensure that you don't defer from those performance objectives, those insights that they want to gather. So quite primarily, visuals are necessary. Relevance, remember we spoke about the KPIs, the original objective, ensuring that it delivers to meet those objectives is key. Timeliness. So old historical data is not always valid all the time. In certain cases, to develop trends, it's necessary. But what's your timeline? Remember, we spoke about 5 years, 10 years. Based on the strategy and the strategy of your company, you're going to need to decide this. Now, remember, we could look at examples of different scenarios where you're targeting, for example, millennials. So there's 20 years of historical data matter. Are you targeting Gen Zs? Does 20 years of historical data matter in that case? No, it doesn't, right? Because your buying patterns are skewed and it's not up to date. So time factor is very important. And so these are the considerations that you've got to consider, because if you're trying to keep 10 to 20 years of data, it's unnecessary. It's also your archiving strategy. So at what point in time do you start deleting data? Because remember, the size of data very much affects how fast your reports run. Another point, are you using data ethically? So remember, if you're collecting data on customers or suppliers, there's going to be factors like the POPI Act, GDPR that come into consideration. Now, are you collecting data of customers globally? Because if it's global, it's not just the local uh, acts that you've got to consider as well, right? It's GDPR for Europe. And how you use this data as well is quite key. Are you storing sensitive data like bank info, ID numbers, and are you linking that to names of individuals as well? Okay, so we talked about reporting and at what level it's developed and how they use it. And remember, we spoke about operational levels and we spoke about more higher levels, for example, at the executive level. And your visualization, your type of report differs amongst these levels. At the executive level, it may be more summarized, and the dashboards may be more effective to speak to that at a more summarized level. But as we progress more to the operational levels, your reports are going to be more detailed. And sometimes that data, that detail is important. The visualization may not be so key to these type of individuals. So your strategy always has to talk to the different levels when you're developing business intelligence in an organization. So what are the challenges and solutions as well? Remember, we spoke about gathering data. Do you have it internal? Is it external? How clean is that data? How accessible is the data? To gather data sometimes is ineffective because it may take you a while to gather proper data to develop insights on. And this is where companies that have already got that data gathered may be quite useful. Data aggregators or companies that do research. But remember, data is not always free. So in terms of your strategy, how effective you need it to be, there's always a cost implication. And when you are looking at budgeting for these type of exercises, whether it's internal or whether you're with a consulting company and doing it with a client, there's always these factors that need to be considered. Poor data quality, we can never underestimate the task of cleansing data and how long it will take. It is much more easier in our current era, and it's getting a bit easier with artificial intelligence as well for cleaning data. So it's also becoming cheaper, but certainly an important fact that you need to consider. So data intelligence is all about deriving a competitive edge amongst the peers in your specific industry, right? And using that to be able to develop optimistic outcomes, higher profit turnovers, right? In supply chain, there's different factors that you would look at. And that's, remember, there's different functional areas in the warehouse, inventory optimization, in marketing and merch planning, replenishment planning, analytics. How do we purchase based on historical trends? Are there any other factors that we are using as well? Industry shortages, natural resources that may be used, and how are we using that to measure or match demand? Where's our demand from? Demand is from our customers. Can we meet those demand? And there's certain aspects like just in time manufacturing, just in time ordering, business intelligence, incorporating these type of um, methodologies is quite key to being able to derive optimistic outcomes. So there's big data, right? And you've heard of the term big data. Big data, quite commonly these days, is large sets of data and being able to derive insights from that. And we talked about size of data before. We talked about the size of data, how much data do you need? These are factors when you're looking at big data. do we want to keep 20 years of history? Because that's quite big data, literally, right? And how effective is that for current insights? Remember, your strategy is going to look at what industry you're in, who you're targeting, that specific consumer market, what are the demographics? We talked about millennials, we talked about Gen Z before, and they haven't been alive, for example, for 40 years, right? So is the data insights really relevant, for example, for Gen Zs? Is it going to matter for Gen Zs or boomers or millennials more? These are factors that will go into your consideration for creating those analytics and business intelligence models, right? So our conclusion is it differs from industry to industry and strategy, the outcomes that you're trying to achieve. With big data, there's three V's that we may look at. Sometimes there's five V's. What are these V's? V's in big data basically refers to volume. Volume, remember, is the amount of data that we are using and at what scale it is created, right? So that's basically the size that we're looking at, right? Think about earlier, we talked about in the first introductory slides, gigabytes, terabytes. Right, now velocity. Velocity is the rate at which the data is coming in, right? So if you have 10,000 customers, you're going to have 10,000 purchases maybe a day coming from those customers. If you have 200 customers, you're going to have 200 purchases coming in a day from the 200 customers. What's the rate? It really differs, right? Based on how many customers and the frequency at which they are purchasing from you. And then there's variety. What is variety? Remember we talked about it earlier? Data types, variety of data types, right? And how are you using that? So if you are deriving insights from social media platforms, example, your data types may include pictures, photos, as well as comments that individuals are making on the social media platforms. And then you're going to derive insights from that. So this is like type of data that you purchase from LinkedIn for when you do a marketing campaign and you want to see what was the market's reaction to this. You can get that from Facebook and you can get that from LinkedIn. And so there's different types of data, different types of comments. The variety is very different, right? So the three V's talk to these type of dimensions when you're looking at data, the speed and generation of the data and the different data types. So there's other types of V's that you get that basically explain different facets of the data, the complexity of the data as well. Okay, so we talked about big data characteristics and different types of industries and where do we derive the data from. For example, if we take an internal view at the data, there's different types of data that will derive from CRM systems. CRM systems are what? Customer relationship management systems, ERP systems that manage the entire business function with different functional modules for different aspects of the business, right? ERP, enterprise resource planning. And if we look at that immediate sphere, we can go and look at other data that we derive from, example, customers, delivery times and terms, on-shelf availability of items, and then think about other types of data that we have, right? So the sphere increases more, and as we look at other types of data, it starts to become a bit unstructured, right? So we spoke about social media platforms, getting data from there. There's weather data as well. There's different types of data, and sometimes these are collected from IoT devices. IoT, Internet of Things, right? And that's basically monitoring like weather patterns in different cities, looking at, example, travel data from what? From cars, from vehicles, perhaps our delivery vehicles, right? And so there's certain aspects that we want to monitor for that. For example, fuel usage, as well as location and time. So in terms of this will differ, remember we spoke about the variety as well. So we spoke about how data is stored, and we looked at simple database models, right? Now, with business intelligence, to be able to draw proper intelligence analytics from data, you've got to store it in certain technologies. And at some point in time in your career as in business intelligence, you're going to have to learn about these factors. And it also evolves from what databases are used, whether you have on-premise, and on-premise means on-site servers, whether you use cloud technology, for example, Microsoft Azure to store the data, or Google Analytics as well, right? So there's different types of platforms and databases that actually allow you to store this data. And one consideration is the amount of data that you're able to store, but also the cost. Cost is a large factor that comes into play. And there's certain points where you've got to do a trade-off. Do you need, for example, we talked about the time aspect before, right? 10 years of data is going to cost you more in terms of data storage, and to be able to effectively retrieve data insights from that, the speed as well, right? And the faster you've been exposed to it, right? The faster computers you want, the more it's going to cost, right? And you can look at your laptop as a simple example. And if you want a larger hard drive, it's going to cost you more. So quite simply, when you were looking at reporting and technologies and the amount of data we're going to keep, we got to look at these factors as well. And so this goes very well in terms of how you define your strategy for your organization, whether you're presenting this back to your C-suite team to consider, and in your next budget proposals as well. Okay, so there's also, we mentioned earlier, predictive analytics, and there's real-time decision making. Real-time decision making is being able to provide insights of data so that we can act on it immediately. And real-time is also quite a key factor because we're collecting data about past events. Are you collecting data that's not relevant to today? Was it relevant to yesterday? Or was it last week, right? Because if it's last week, your data is already 5 days old. And that's going to be an issue. Is it really relevant to be able to act on the data tomorrow, for example? And there's different industries that you'd have to look at, right? If you're looking at stock levels, data that is 5 years old may be inconclusive for you to act on. Okay, so big data collections and practices. We looked at this earlier, right? Looking at data breaches, GDPR, POPI, there's certain implications of keeping certain data. And in your strategy, you're going to have to look at what data do I keep? And is it really necessary to keep that specific data? You don't need to keep bank account numbers. You don't need to keep ID numbers. So don't keep that because it really affects your company if there's a data breach, because you could very well be fined for some of those practices. How you secure the data, you're going to have to declare how you secure the data. Okay, so we spoke about IoT before, and IoT is really relevant because of, as I mentioned, the data that we're collecting. And remember, it differs from industry to industry. If you're in the logistics industry, you're going to be collecting data from IoT devices that are, for example, in your delivery vehicles. And at what speed is this coming in? If you're developing new cars that measure fuel consumption, and many of the new cars are connected online to databases where manufacturers are able to collect that information and refine what's the fuel, use it for the research and development based on, for example, factors like what's the fuel usage, how fast you're traveling, where are you, is there high altitude, low altitude, are you using more fuel, for example? And that is really how IoT devices have had prevalence in terms of collecting the data and helping manufacturers, for example, fine-tune and use this in the research and development. So if we look at industry 4, that's where we have our IoT devices. But from industry 1, where we had simple steam mechanization, steam engines, it grew to Industry 2, where we were able to convert that steam power into mass production. And then Industry 3 was basically computers, the early development of computers that helped, for example, automate payroll systems. And now in the fourth industrial revolution, we have IoT devices and even artificial intelligence that is prevailing now. So how are we using artificial intelligence for business intelligence reporting and big data? Are we incorporating artificial intelligence with large learning language models, for example, LLMs, to be able to derive insights? Quite often now you can actually connect AI to your reporting to be able to derive insights real time from the market as well. And this is a key factor that you've got to consider in deriving business intelligence and big data. Machine learning. So machine learning is a term, when you talk about artificial intelligence, goes hand in hand, right? Machine learning is very basically how you're using the data and how are you using the data to derive insights. Sayuri, I see we have a question in the chat. Sorry, are you able to read that out for me and I can answer that? Okay, I'm not sure if I've lost Sayuri. I'll continue. Okay, so we talked about machine learning and it being a discipline of artificial intelligence. So incorporating machine learning into your business intelligence reporting is quite key, because there's certain aspects that you would use, for example, and these are the use cases, for example, credit scoring, trading, for example, of real-time data, or getting market insights from social media platforms to determine how should I make the next trade. So incorporating artificial intelligence and machine learning to mine that data and give you insights is quite key as well. Remember, differs industry to industry, but this can actually lead to more optimistic and accurate outcomes as well. So we've talked about data science, and data science has similar phases, remember, that we spoke about earlier in terms of how we develop reporting. And look at this, right? We spoke about data collection, data analysis and modeling, which is defining that logic in terms of how I derive certain analysis. Data science also includes validating that model, that logic that we used here. Is it actually valid? Is the outcomes key for us to use in our portfolios as well? And if it's key, then it's insight and decision making that we can actually derive from that, right? So the data lifecycle model or life cycle is understanding business requirements. We spoke about data mining, what our data sources is, how we're going to mine the data. Data cleansing, do we need to cleanse that data before we develop proper insights from it? And that's insights that we know about, right? But is there other insights that we can determine from the data? Remember, we spoke about hypothesis. I have a theory. Can the data that I have answer that theory? So what's our strategy? And you find that many research and development companies are able to use this data to develop those insights and predict how we can use it or certain outcomes. Okay, so there was a few questions, and I have a question from Wazizwe. Hi, which visualization tools will be covered in this course? So Wazizwe, I'm not able to answer that question quite properly at this moment. Tableau, as we showed as an example before, will be used in the course. And Tableau of their website, and I've included a link in the PowerPoint presentation, is where you can actually navigate to the website and view their tool, how it performs, how it delivers certain insights, and how it does it visually for you is one of the tools that will be covered. Nazish, is all of this taught in the postgraduate degree in BI? Yes, so when we look at certain of those factors that we looked at and how data is built up from those phases of how we develop reporting, that life cycle, those different V's, the type of data, the structures that you have, yes, you will be exposed to those concepts and in more detail, right, as well. And is data science offered? Data science is incorporated in many of the programs as well. Business intelligence is not just the only program, but you will come across much of these data science terms, artificial intelligence, digital technology as well, and how you use that, how you relate that to your strategy. Billy Kazi, in building an automated replenishment portal between a distribution center and suppliers, what data governance or integration challenges should one anticipate to ensure it aligns with future for BI strategy? So an automated replenishment portal, right, between a DC and suppliers, the integration challenges, right? We spoke about stock levels. How do you integrate stock levels into those data portals, data integration? If you are able to know that a supplier has certain stock levels of an item that you're going to have in demand in the next week, it would make sense to have integrated with the supplier, know that they have high stock levels, and perhaps in certain regions, and buy that ahead of time so that you don't have issues with your supply chain and your manufacturing. So one of the integration challenges for companies that are not integrated is not knowing this, right? And guess what? If you have a high demand that you're expecting next week and none of your suppliers have this, you're not going to be able to deliver on that consumer demand. Being able to integrate to suppliers actually mitigates that challenge in that you would be able to know what the stock levels are and be able to plan for it accordingly. Okay, so there's business intelligence and data science. And data scientists, as you would have heard of, also create business intelligence reports. A lot of other concepts and skills are used, right? We talked about statistics. Statistics is used there. Programming languages like Python is used as well. Okay, I have another question from Pablo. Sorry, I may not be pronouncing the name right. You spoke about storytelling using data with reference to the pyramid. You should indicating the level of details. How does one determine what is relevant for, say, tactical versus executive level storytelling? Okay, so we spoke about the different levels, guys, and the slide looked at transactional data as well as the different levels from an operational level. Remember, at an operational level, transactional data may be quite relevant for staff at that admin, operational, the clerical function. And knowing what stock levels in an exact whole number is necessary. Now, that may not be relevant to an executive. He may be looking at what our stock levels are from a percentage perspective and what are our out of stock levels. So he may look at it not from a very specific number level, but want to look at it as a graph as well. Maybe a bar. Remember, we looked at those Tableau visuals and how they had bars. A bar is easier to read than looking at a 80% or a stock level of 1,050, right? So that's, for example, some of those key differentiators for visualization and what type of data they may want to visualize, especially at those specific levels. Clayton, With the emergence of AI, what does the future of data analysis look like and how we can leverage it? So that's a key question, right? And we spoke about real-time decision making. How do we use real-time decision making to make decisions as well, right? Remember, we spoke about artificial intelligence earlier and how we're using that and large learning language models to ensure our data is relevant. Now, using AI, incorporating that into big data models, for example, we said, how can we monitor the market or monitor that certain brands may start selling well based on certain criteria? We can use data mining or artificial intelligence to look at getting this data from